Hi friends, welcome back in the another video of decision tree. So in this video we will do analysis on the car MPG dataset. So here we will apply a decision tree. So let's start with one by one. So first we are plotting all the necessary library like matplotlib for plotting graphs in Jupyter notebook, then inline libraries or then numerical libraries like numpy, right? Then train test split from model selection, then importing linear regression machine learning libraries, or in this way today we are using decision tree regressor from tree, then to handle data in form of rows and column, or to work with the data frames we are using pandas, then importing the plotting libraries like matplotlib.pyplot, then importing seaborn for statistical plots, right? So here you can see that we are importing it from Google Colab. So we did the testing with this Jupyter notebook in Google Colab, where we pass the uploaded equals to files.upload, which allowed us to upload the CSV file, right? So the upload widget is only available when the cell has been executed in the current browser session. So here you can see that it is disabled now, but if I run all the libraries again, all the code again, it will get activated. In your case you can also run your cell and try it out. Then we are getting this CSV, so car mpg.csv, then car mpg, we imported this CSV, right? Then reading the CSV file into the pandas data frame, so mpgdf equals to pd.read car mpg.csv, then check top few records to get a feel of the data structure. So getting 100 top 50, right? So here you can see that we have mpg attribute, cyl, disp, hp, weight, acc, year, origin, car type, and car name, right? So this was the sample data. Then we are getting the describe, right? Calling the describe function. So here you can see that we are getting description with all the min, max, and average, right? So here you can see that yeah, again here as well there is missing the horsepower, right? HP you can see here, but we didn't get that HP here, right? So what we are going to do next is we are telling that okay, in temp variable just read our data frame, read that mpgdf.hp, right? Take that string and check if it is digit, right? So here we are checking that. Now temp hp equals to false. So here you can see that if it is digit then false, right? Next we are imputing the null or symbols. So what we are doing is mpgdf.replace if there are any such symbol like question mark, so convert that into none values. So if we get the df.info, so here you can see that mpg non null, all these values are non null now, right? Now we are converting our horsepower into float 64, because here you can see our horsepower is of object type. So once we have converted into float 64, now we are defining a numeric columns, mpgdf.drop, we are dropping the car name x1, that means column. Copy the mpg column alone into the y data frame, this is the dependent variable, right? So car names equals to pd.data frame mpgdf car names we are getting here. Now numeric columns equals to numeric columns dot apply lambda x dot fill na x dot median, right? Access equals to 0. mpgdf equals to numeric columns dot join car name. Now we are recreating mpgdf by combining numerical columns with car names, so mpgdf dot info. So here you can see. Now let us do a pair plot analysis to visualize or visually check study the data, right? So this is done using scatter matrix function, which creates a dashboard reflecting using information about the dimensions. The results can be stored as .png files and opened in say Paint to get a larger view. So gdf attribute that mpgdf.ilog, so we are accessing all these values. Now mpgdf attribute dispracy, mpgdf attribute disp divided by mpgdf attribute cyl. So here we are getting the dispracial column, right? So here we are getting the dispersal column. Okay, now SNS pair plot mpgdf attribute. Okay, we are pair plotting it with kde kind, and origin is u over here, to plot the density curve instead of histogram. Okay, so here you can see that it has plotted the pair plot for our mpg. Now the step 5 is decision tree regressor. We will apply it now. So from sci-fi.stats import gscore mpgdf attribute mpgdf.log, right? Again accessing these mpg and origin rows, and mpgdf attribute z mpgdf attribute dot apply the z score. Okay, so here we are popping, that means dropping the origin and dropping the year. Now array equals to mpgdf attribute z dot values x equals to array. It will select all rows and first 4 columns, right, from 1 to n minus 1. So this is for all rows and this is for 1 to 4 columns, which are the attributes. Now y equals to array, again select all rows, right, and the 0th column, which is the classification, or in our case it is yes, and again no for diabetes. So here all rows with 0 columns, here all rows with 1 to 4 columns, right. X train, x test, y train, y test. We are doing train test split with 30% of test size, remaining 70% will be our train size. Random state is again integer 1. Regressor equals to decision tree regressor, random state is 0, max depth that is 6, right. Regressor dot fit x train, y train. Feature importance, we are defining regressor dot feature importance. Feature name mpgdf attribute dot column 1 to 8, right. Printing feature name, so k equals to 8 here, printing feature importance over, right. Now top k idx equals to feature dot importance arg short. Okay, this function, and accessing these values, then printing feature names top k idx feature importance. So here you can see index that we got is cyl, dispatch p, watt, wt, acc, year, origin, and the values for them is respectively, and second all these the value for them is respectively. So the first one is feature names, right, then the feature importance. Okay, then second, then we have feature name for top k idx and the feature importance for them. Now let's design or build the decision tree. So importing the export graph, which 6 string io python dot display image, display this image, py dot plus, right, dot data equals to string io, export graph is regressor, out file equals to dot data, field equals to true, yes, everything is filled, rounded equals to true, everything is rounded, special character equals to true, feature names we are doing for cyl, hp, wt, disp. Now graph pyplot plus dot graph from dot data dot get values function, graph dot write png, car dot png, image graph dot create png. So here you can see that this is what our decision tree will look like, right. So if I zoom it in, so this is our root node here, right. cyl, if less than equals to 0.027, it will give squared error as 1.017. sample it is taking 278, value 0.011. if it is true, this will go in this branch. If it is true, this will go in, sorry, if it is false, this will go in this branch. Then there is another node, then there are leaf for them, right, and at the last you can see that how it is distributed to the leaf nodes. So yeah, this was the decision tree. Now y prediction equal to regressor dot predict x test, and important importing seaborn again, right. So dark grid, here we are plotting a joint plot, right. So sns dot set style dark grid, here you can see that color codes equals to true, with sns dot access style white, right. sns dot join plot, x equals to will be our y test, and y will be our y prediction, kind equals to reg regular, color equals to k, right, the color that I'm talking about. So you can also verify that, then you can see the x and y values and the joint plot for these, right. how it is scattered. If we do another iteration, so this time dropping ACC column based on the above visual analysis, so mpgdf attribute z dot pop ACC array equals to mpgdf attribute z dot values x equals to array all the rows and selecting column from 1 to 4, then y equals to array all the rows only 0th column, x train x test y train. For train test split we are taking test size as 30%, remaining 70% will be our train size, random state equals to 1. Now regressor dot fit, right, function calling is here for x train y train, y prediction will be our regressor dot predict x test, regressor dot feature importance. So here you can see array equals to array, we are getting an array of all these feature importance values. So now we have some observations here. What are them? First is the mpg column for the different brand name are suspected, right? Font value much larger than the factory values for the cars, and definition of mpg 2 may have to be logged at. Second is the weight of the car 2 is suspected as they differed from the specification for those model. There are different, let me mark it down and let me make it at a raw material so that we will get it clearly. Yeah, so there are different types of weights was the data collected consistently. The HP column 2 had values different from the factory specification. There are different types of HP values, and one of them was the standard definition followed by suggestions, right? For those instances where the declared mpg is greater than factory mpg, replace the factory mpg similarly for other columns. So when this was done, the standard distribution for the mpg columns fell by 50%. This was the some observation that was done by our team, right? So you can also analyze it by yourself, just go through it, type code and get the insights, right, which will help you in your analytics and AI skills, right? So yeah, this was all about the car mpg, right? So this is how we done the decision tree in that. So hope this video was really helpful. If it is, just do like, share and comment. That will also motivate and will help us, right, to make such relevant contents. So yeah friend, thanks for being with us. Have a good time.